Give me 1 second, please. Do you see my screen?
Yeah.
Nice. Okay. And thank you very much for joining this session today. My name is Smash Miriam, and I'm a security solution architect. And for this next 45 minutes, we are going to discover together. Sorry, maybe you don't are not able to see me, right? Just
I
1
think
second.
your video's not on yet.
Yeah, here I am. So yeah.
Your video's on.
Hi again. So as I said, during the next 45 minutes, we are going to discover together how AWS AI services can be used to build customized security solutions. And yeah, I'm talking about using Amazon Bedrock Agent Core, and the Model Context Protocol (MCP). All of them, they will play an important role to help you build security agents that are able to think, decide, and react in a more autonomous, proactive, and dynamic way. All of them, the goal together through the solution that will be provided today, they will be able to answer to your specific business security journey and really so customize it. Each component is able to build an addition value that the rest are not able to do. Okay, so what do I have in my agenda? We will discover together what is Amazon Bedrock and how it can be used for to provide a secure rezoning and enhancing the security data analysis in a very customized way. Then we'll explore together how Amazon Bedrock Agent Core can be used to build autonomous security agents able not just to think but also to decide instead of humans. Then we will understand together what is the role of MCP and why are we insisting on presenting this today. MCP plays an important role through this environment for the agentic systems. And here we are talking mainly about the centralized agentic system if you are handling the MCP in the game. So let's start with discovery. And here we are talking about the foundation. Foundation means Amazon Bedrock, which is AWS is fully managed AI service. Through Amazon Bedrock, we gain access to a diverse and multiple, I would say, foundation models through a single API. And this will allow you to choose the most suitable model based on your data set, based on your security requirement, based on your business logic. We have a bunch of foundation models in Amazon Bedrock, and Mark already mentioned that during his presentation. It is all about building a smart agent with a minimum of code and infrastructure work. Amazon Bedrock will offer you access to many foundation models, as I have mentioned, like for example, Cloud from Anthropic, Amazon is on Titan model, and other state-of-the-art LLM. Bedrock provides strong capabilities designed for critical security scenario. So you choose your model, you customize it based on your needs, and then you benefit from the enterprise grade security, privacy, security, safety features to handle the most sensitive security scenario. Why? Because most of our services, including the AI one, they are secure by design. So by adopting one of them, you are already inheriting some security controls interesting for your security best practices. And all of that, I mean, talking about the enterprise grade security, it depends from your scenario, how much is sensitive. Are you working in finance? Are you working in health, mission critical? This choice of the model, it really depends from what do you have on table. Starting with the first one, which is the customizing capability that is provided by Bedrock. So the goal here is to enable your model to understand and respond to your organization's unique security landscape, whether that's detection, incident response, compliance, monitoring, security policy, and you will see some examples in the next slides. or maybe security policy enforcement. All of that while maintaining the context and the needed nuances specific to your environment. Available customization approach, something I guess today that is known. We spent like 2025 just talking about that. Here we are talking about prompt engineering, and it is the fastest approach. You craft the prompts to guide the model, its behavior and reflection. Then we have RAG, it is the retrieval augmented generation. It integrates external knowledge sources like, for example, some your security run books that you are adopting in your organization, your security policy that you would like to take in consideration, threat modeling, threat intelligence that you have, also some historical incident data. This is going to be interesting too. And then the third one, sorry, it is the fine tuning. Here it is about adapting the model specifically to your organization's security patterns and use cases. Finally, it is the training from scratch. So you provide maximum control in this case by requiring significant resources and expertise. It is really making the training from scratch. For the security scenario that we will explore today, we recommend prompt engineering combined with RAG. I guess this is enough to provide the autonomy and adaptability you need. This approaches, and I see this question somewhere during the chat, will provide for you a fast way to implement and iterate, will provide for you cost-effective enterprise deployment, and it allows you to maintain full control over your sensitive security data. But if you'd like to go more than that, more far, so yeah, you can train from scratch, but it's going to be a little bit expensive. Not just the customization, Bedrock also provides many security features to handle the security sensitive workload. Starting with the first one, which is really one of the most important security features, it is mainly the privacy and data isolation. Your prompts and response are never used to train other models. Bedrock supports VPC, Virtual Private Cloud, endpoints, keeping your security data within your network perimeters with a full encryption at rest, here talking about AWS KMS, and full security in transit, talking about TLS. Second thing, and already Shweta mentioned it is guardrails. So this actively blocks sensitive data leakage, automatically redacts secrets, credentials, and personal information that maybe can be handled in your data, and enforce output format to prevent unsafe responses. So at that time, you get programmatic control over what goes in and what comes out. Third thing, it is the critical security. I guess it is like it is the adopting the native AWS security service. And this is really interesting for security team. Why? Because Bedrock seamlessly will connects with other AWS native security services. Already Shweta mentioned a lot of them during her presentation. Like, for example, Security Hub, GuardDuty, CloudTrail, and Security Lake. It ingests and analyzes the security logs coming from these different tools, talking about Bedrock absolutely, and alerts in real time, enabling AI-powered zoning over your existing business metrics. Finally, talking about enterprise security posture, and yeah, mentioning some controls that you can inherit, like for example, the fine-grained identity access management policies, control model access, and also you can inherit some compliance controls. You can be aligned, but you know this is a shared responsibility model, so we are doing the half path from the compliance, but it's up to you to work on the rest. It is like SOC, GDPR, for example, because we are ensuring, for example, the encryption, and you get model invocation logging for the security monitoring. The bottom line that I would like to highlight: Bedrock isn't just a secure AI service. It is a comprehensive security platform that integrates naturally into your existing AWS security architecture. And that's exactly what we need to build smart security processes. So we will take some referenced architecture for Bedrock, for Agent Core Bedrock, and for the MCP. But please keep in mind, those that are referenced architecture. That means some details can be added to be really to be applied in more customized use cases. So starting with okay, sorry, I was on this one. Yeah, here we are. Starting with practical cases for Amazon Bedrock when we would like to provide the secure rezoning. So, with this customization and the security feature in place, Bedrock brings three capabilities to the table, or I would say may help us to ensure three capabilities. The first one, it is dynamic threat detection analysis, and then intelligent security operation. And also, it is not mentioned in the slide, but it's something that I would keep all the time mentioning. It is that through the use of the secure rezoning, you are adopting for an enterprise a great security. When it comes to the dynamic threat detection, we are talking about a smart analysis for the logs. We are not just doing a static collecting for logs without correlating them, without making any meaning for the context. We are also using an automated correlation through all these logs to make the right analysis in a dynamic way. Also, we can help through this approach to make a more robust, secure code review and application security analysis in your CI/CD environment. So we are taking a lot of security operation from a static static approaches to dynamic. I would say also a robust way to analyze them to have the most precise and accurate results. If we can take an example, let's suppose, for example, that what a human, like in a static way, would ask within, like, let's say, an age use case. Please, if this IP address makes one-handed request, block it. So basic response or basic action, IP blocked after one-handed request. What do we expect from our smart model, smart agent, is that you will say, I would say when one of our Bedrock models would answer, it will provide. This IP address shows credential stuffing pattern. We are talking about 500 login attempts with different user agents. Same IP address tried also the SQL injection earlier. IP is from a known VPN provider. So what we recommend you is to block and monitor the related IP. This is what we call dynamicity. It is not just to say, yes, you blocked it, but we are providing the analysis. Why are we doing that? What happened? And what is the recommendation? Let's take an example with the identity access management. Here the challenge is that we have identity access management permission that are incredibly complex, when it comes to a scalable application. You need to detect the overprivileged roles across hundreds and even sometimes millions of accounts. A reason about the nested policy logic. You need also to translate those cryptographic JSON policies into a plain natural language. It can be English, French, I don't know, Spanish maybe. Yes. And so that after that, your team need to spend, I don't know how many time, I don't know how many hours to actually understand, analyze, and then make the recommendation, remove maybe accounts, reduce the privilege. And we are not sure how much that work was done in a correct and precise way. So how does Bedrock help? Bedrock will analyze and generate the security policies based on your specific requirement. It reviews your existing policies for misconfiguration, privilege escalation risk, things that they are easy to miss when we are doing some manual reviews. And then it suggests least privilege improvement with contextual rezoning, understanding not just the syntax, but even taking in consideration the context and also the security implication for your business logic. Bedrock here is giving a lot of value from it comes from security point of view. I have mentioned that, but I would like to make it more customized for this use case. Bedrock will follow policies AWS best practices while maintaining confidentiality. We are talking about the VPC integration. What that means like the sensitive identity access management data within your net will be kept within your network perimeter. Then we have the guardrail. The role of the guardrail in such business use case or security use case, it will prevent exposing account IDs, role IRN, and other sensitive details that are not supposed to be exposed externally. You get full audit trail also through the use of cloud trail for compliance and governance. And this will help us to bring intelligence to one of the most complicated security challenges, which is identity access management. You are gaining time, you are gaining dynamicity, and also you are working to provide a very efficient way to control the privilege in your accounts. This is again a referenced architecture that can be enhanced. Some details can be added. We are just referring this to give you an example how this may work. So let me walk you through this possible architecture. Starting on the left, we have our identity access management data sources. Here we are pulling more than 4 key sources. Identity access management policies stored in general as a JSON document. Then we have cloud trail logs capturing actually the actual API usage. We have the access analyzer findings, identifying security issues, and then we also included the organization's SCP for governance policies. So having these different data sources or identity access management data sources will provide for you a complete picture of both what is configured and also what is actually being used. Moving to the center left, here we have our policy storage and indexing layer. Talking about raw logs flow into Amazon S3, and then we will use Amazon Athena to query Cloud Trail data directly. This creates a queryable repository for all our identity access management activities and policy information. This data then it will move to the RAG pipeline. And this is where context retrieval happens. Amazon Kendra serves as our threat intelligence knowledge base, indexing policies and security best practices. We added Lambda, and Lambda will act as our policy parser. And then also we added step functions that will help us to orchestrate the entire workflow. This pipeline retrieves the relevant context we need for intelligent analysis. Then on the other side, we have Amazon Bedrock with the model that you choose, and this will provide for us the AI engine that brings it all together. Bedrock receives the context and policies from our RAG pipeline and performs mainly two critical functions. Analysis capabilities, it parses identity access management policy JSON, identify the over privileged permission, correlates the findings with the actual cloud trail usage, and then all of that will be sent to the generation capabilities. So it will give you the recommendation of the list of privilege policies that should be automatically maybe deleted, or created remediation playbooks, produced for you some compliance reports. All of that can be done through the use of your specific and customized model. So sorry. Okay, do you still see my screen? Yeah?
Yes, I can see it. Yeah.
Okay. Okay, just 1 second, sorry. Okay, so the key point here is that this isn't just a static analysis. It is AI-powered read zoning reflection over your actual and your current identity access management data, combining with what is configured, what is actually being used for the context-aware recommendation that we need to provide for you or maybe for your security team. And this is really a good example to adopt when talking about enforcing list privilege at scale. Again, this architecture, it can be optimized. This architecture, it can be enhanced in order to provide the most customized solution, optimized one to your architecture. Second example, it is the secure code review application security and CI/CD. And this is another critical use case. The challenge here is catching security vulnerabilities before they reach production. So you need to analyze application code for common issues like SQL injection attacks, cross-site scripting, and you need to do this at scale and across every commit without slowing down your development pipeline. How Bedrock helps, I would say how the model from Bedrock can help. So the model that you will choose will be able to analyze your code with contextual understanding, not just like pattern matching. They identify security anti-pattern. They will also suggest security coding practices, specific to your framework, and will provide the needed recommendation for remediation with your actual code example. And this is really good example when it comes to the secure code and what kind of security Bedrock is providing. So Bedrock in this case will provide you the VPC integration in order to help or maybe to be sure that your code and your I would say your most important asset, the code, is staying private during the analysis. It never leaves your network perimeter because we are ensuring mainly to deploy the private link to ensure that they are kept and your network. Then we have guardrail, and guardrail plays an important role in this case. Why? Because it prevents exposing any sensitive code, snapshots, I would say API keys, credentials that may be hard coded in your code base. And this example, it is about the shifting security left to the shift left. Catching vulnerabilities at the earliest stage of the development pipeline while maintaining the confidentiality and the integrity of your most valuable asset, your code. And here we adopted, or I would say we take screenshots from an example which was implemented through Amazon Q, something that already Shweta mentioned. It is important to keep in mind that Amazon Q is implemented based on one of the model coming from Bedrock. And here we are talking about 4 critical issues that were detected. Inadequate error handling, we have the CWE94 vulnerability, and we have also 6 high severity issues that also were detected. We have the infrastructure misconfiguration, disabled monitoring, and touched identity access management profiles. And just in the center, if you can see, we have the classical CWE94 vulnerability, and this in general is about the user input with input. Like for example, the example here, it is giving the directly executed via the as literal eval. It is inadequate error handling. Yes, and also it may create some denial of service and information disclosure risks. So what we did, we had a chat with Amazon Q, asking to provide a more smart remediation, implement the proper input validation, add a try except the blocks, use dedicated mathematical expression parcel library. And then you can see that the operation was completed and the security findings with the exact file location, line number, and the column references. Key value here to keep in mind. We are talking about an AI-powered contextual understanding versus static analysis of your code. We are talking about the ability to analyze that happened within your IDE in your private network. And the most important point is that we are catching vulnerabilities in the developer workflow before production, which is the shift left security that we are applying. Next example. It is the smart security signal analysis and correlation. And the challenge here is we have a lot of modern AWS environment that generate massive volume of security